Good morning. This time we are dealing with our graphics lab experiment for projection.
Continue.
Here is the code for our projection experiment. What exactly we are dealing is that we are dealing with two types of projection, oblique and orthogonal. For orthogonal, we are directly passing the coordinate and changing it. For oblique, we are providing two like the provided combinations like cabinet and caliber. For the code, just a second. Here's the main function where we are asking for which type of shape are we providing, a line, a point, triangle, or a square. How many, if we are asking for the angle and the type of projection we want. The orthogonal projection is represented in white, for oblique projection is represented in yellow, and it's asking for which option we want, lever or cabinet.
Okay.
Our next function is that how we are taking the inputs from the user about the coordinates. So basically, whatever shape we are asking for its coordinate, and we are substituting in this coordinate. These are the number of iterations for each coordinate, and here is the input taking out, and we are and then where we are taking the inputs.
So after taking the number inputs for the choice of polygon, which can be point, line, triangle, or any number of vertices, we plot the orthographic projection. We'll go to the orthographic, like here is a function which calls out for the orthographic projection, and we'll go to the function. So here's where the calculation is done. So if the polygon has one vertex, we'll just simply plot the output, and if there's other polygon which has more than one vertex, here is we are plotting simply the polygon here, the line, and we're joining the points which is inputted by the user. So, and here's the orthographic projection. So after the orthographic projection is done, we'll ask the user whether you want to, which type of oblique projection you want, a caliber or a cabinet, which is calculated here. Oblique. So if the choice is one, which is a line, if its choice is one, which is the caliber projection, we'll calculate here, putting the formula. Here's the formula. So here we'll calculate the points of the projection. So for cavalier, the angle is 45, and for cabinets, here's the angle. So here we'll calculate and plot the points. So the points are plotted here. Here it is, we'll plot the figure. It's simply the for function, and it will plot the figure. So it'll take it, we have the values stored in the array. Here it will plot the figure. So let's run the code. First compile. So we'll take, let's say first we'll take a triangle, putting angle as, so the points would be, so we'll input the points in the order of drawing. So XYZ coordinates. So we're inputting the points, the output would only be the projection, which would be the orthographic projection or the oblique projection, whatever we choose for. XYZ. So it could be random, like I'm putting these points, we could put any other points in a 3D plane. Yeah. So here's the orthographic projection. So yeah, and if you want to see the cavalier projection of it, we'll put one. Here's the cavalier projection of a triangle, a 3D triangle, and also the yellow one is the cavalier, and the white one is the orthographic projection. So we will try with another shape. We will take square this time. So you have got the points. We'll take square between 4 vertices, angle 5. We'll take 1. So square will take. We won't take a complex one. So because we can take a complex square, but it's too. We have to calculate it, and so Sorry, 50. Yeah, anything. You can take 50, anything. It should be a square. Not a anything with 4 vertices. What is 4? So take 50 here, then 0, 400, and 0. So here's a square with
Orthogonal projection.
yeah of the orthogonal projection of the square, and we'll take cabinet projection of the square this time. So this is the cabinet projection. The angle is 63.43. So this.
So here we are projecting for the projections of a cabinet, orthographic, and cabinet. Thank you.